Here's the solution to one of the exercises from section 1.5. In this section, we're really trying to use our power rule for everything. And so the only catch to some problems is that we need to use our knowledge of algebra to rewrite the problem before we use our derivative rules. So in number 14, we have a good example of that because we have something with the cube root with a 5x underneath. And so that by itself is not exactly what our power rule refers to. For our power rule, we like that to be a number times the power of x. And so we want to see if we can rewrite that as a number times the power of x. And we can in this case because when we have something to a power, like 5x to the 1/3 power, remember the cube root would be really a 1/3 power. When we have a product to a power, then we can separate the power across the product. This makes sense. It's really because multiplication is commutative. Remember that the 1/3 power means that so this originally, this is not relevant, it's just why the rule works. This guy, when you say it's the cube root of 5x, that means when you multiply this times itself 3 times, you're going to get 5x, right? So the cube root is whatever you would have to multiply by itself 3 times in order to get that number. So the cube root of 5x means you multiply this by itself 3 times, and you will get 5x. Well, if you look at it, if you multiply this by itself 3 times, because multiplication is commutative, in other words, the order that you multiply doesn't matter, if I do 5 1/3, 5 to the 1/3 times x to the 1/3, times 5 to the 1/3 times x to the 1/3, times 5 to the 1/3 times x to the 1/3, I'll have multiplied 5 to the 1/3 3 times, which is 5, and I will multiply x to the 1/3 3 times, which is x. So multiplying this thing by itself 3 times is going to give you 5x, and that's what 5x to the 1/3 means. So anyway, so this rule does work. You can distribute a power across a product. The general exponent rule is like this. If you saw it written down in a book, it would say ab to the n power is a to the n times b to the n. You might have seen it written down as an exponent rule that way. But that's what's happening here. The reason that's relevant is that this is just a number, right? I mean, I don't know what it is. You have to put it in a calculator to figure out about what it is. But it's just a number. So this really is a number times the power of x. So when we calculate this derivative, the derivative of 5x to the 1/3 is the same thing as the derivative of 5 to the 1/3 times x to the 1/3. And that's the same thing as, well, we know that when there's a number, we don't have to do anything with it. So this number here, this 5 to the 1/3, is just a constant, so we pull it outside and then worry about the derivative of x to the 1/3, which follows our normal derivative rule. So the 5 to the 1/3 just sits there, we're ignoring it, and the derivative of x to the 1/3 is 1/3 times x to the negative 2/3. So our 1/3 power becomes a constant in front, and then the new power of x is 1 less than the original power of x. And so if you enter this exactly like that, I know there's nothing really to simplify here because there's no way to combine this 5 to the 1/3 times 1/3. There's really nothing you can do with it. And so if you really write that 5 to the 1/3 times 1/3 x to the minus 2/3 exactly in that box using these little tools, you don't have to change it back to radicals or anything like that. It will. I did it. It checked it, and it did say that was correct. So you can put it into the computer exactly as it's written on the page.